Hi! Today we're going to learn about creating a least squares regression line in statistics. So let's say we have a problem like this. Calculate the least squares regression line and the coefficient of determination given that x bar is equal to 5, y bar is equal to 7, s sub x is equal to 2, s sub y is equal to 3, and r is equal to 0.8934. So before we get started, let's first recap on what these terms mean. X bar means the average of all the x values, y bar means the average of all the y values, so the response variable and the explanatory variable. S sub x is the standard deviation of x, S sub y is the standard deviation of y, and r we know is the correlation coefficient. So let's start off backwards in this problem. So the easier way to do this is to first figure out the coefficient of determination, because that's easier. So what is the coefficient of determination? Well, the coefficient of determination is r squared. So it's simple. All you have to do is just find the square root of r. So let's do that in this problem. So if you put on your calculator, then you get r squared is equal to 0.8934 squared, which is equal to 0.781, or 0.782 approximately. 0.782. So that's the answer to part B. Now let's figure out the least squares regression line. So before we dive in, let's figure out how to find it, given these terms. So we know that the least squares regression line is a linear line. And the form of this line, or we know the form of this line is linear, but this line we know is equal to, y hat is equal to a plus bx. So now there are a few things. Well, we know that the least squares regression line must go through x bar, y bar. So that's one point that we're given. And we know how to find the slope b. So the slope b we know is just, and this is just a memorized formula, b is equal to r, the correlation coefficient, times s sub y, over s sub x, so the standard deviation of y over the standard deviation of x. So because this is linear, and we know what type of form we want, we can find, or we can make a least squares regression line that doesn't exactly follow a plus bx, but uses point slope form instead. So we would get y hat is equal to r times s sub y, or to make this less complex, let's just say b, because b is the slope, b times x minus x bar plus y bar. But there's a problem here, and the problem is that whenever you have the least squares regression line, you want it to be in the form a plus bx. So what should we do? Well, it's simple. We just want to convert this into a plus bx. So here, this is equal to bx minus bx bar plus y. Plus y is equal to y hat. So if we group these in terms of a and bx, so we separate the constants from the coefficient and x, we get that y hat, I need to erase something, I'm running out of space, I'm going to write it up here. We get that y hat is equal to bx, or is equal to negative bx bar plus y bar, which we can rearrange as y bar minus x bar, or minus b times x bar plus bx. So this is just the rearranged formula for calculating the least squares regression line given these. Now let's identify a few things. So we want it back in the form of a plus bx. So, yes, if you didn't get that, then you can go back and pause the video. So, the next thing to do is we want it just with A and just with Bx, and we want a cleaner look. So we can just write this. Y hat is equal to A plus Bx, and A is equal to Y hat, is equal to Y bar plus B times X bar. And B is equal to R times S sub Y over S sub X. This here is a memorized formula. So it gives us a better look. So what we have to do is we have A is equal to Y bar plus B times X bar plus B, which is equal to R times S sub Y over S sub X times X. So let's answer our problem here. So we get Y hat is equal to A, which is Y hat plus, or Y bar plus B times X bar. So let's put that into a calculator. We have Y bar, or 7, plus B, which we know is this thing here, so we have in parentheses the correlation coefficient 0.8934 multiplied with the fraction S sub Y, 3 over 2, which is S sub X, plus, that's it, times X bar, which we know is 5, so multiplied by 5. And so this gives us 13.7. So we have Y bar plus 13.7. Or sorry, we get A is equal to 13.7. So it's 7 plus this value here, which we put in the calculator, times 5, which is X bar. And B we know is just this thing here. Now we have plus Bx, so B, let's put that into the calculator, is just B, which is 0.8934 times 3 halves, is equal to 1.34 multiplied with X. So the answer to this problem is Y hat is equal to 13.7 plus 1.34x. And also another thing that you should know is that the direction of this, so when you're talking about a bivariate distribution, the three things that you have to talk about are direction, strength, and form. So because this is linear, we know that, because this is A plus Bx, we know that the form is linear. And because this is positive here, we know that the direction is positive. And then the strength is moderate because R is 0.8934, but it's close to high, or close to strong. So those are just the three things that you should talk about when describing bivariate distributions. Today we learned about creating a least squares regression line in statistics. Thank you for watching this video.